Hello, Honors Trig Pre-Calc. We're going to be doing sections P.3, P.4, and potentially P.5 today, but we're going to kind of play it by ear, see how it goes. Let's start with P3 with linear equations and inequalities. So we've got a couple definitions of properties of equality, and we're going to start with the first one, which is the reflexive property that just says any number is equal to itself. So A is equal to A. Very simple. You look in a mirror, you see your reflection, you see yourself. The second is the symmetric property, which says if A is equal to B, then I can say B is equal to A. Symmetry, right? I can switch the way it is and it still is the same. Third, transitive property. I like this property a lot. It has a lot of ways we can use it outside of math, and maybe we'll talk about that in class, but the transitive property says if A is equal to B and B is equal to C, then I can cut out the middleman and I can say A is equal to C. So those are our properties of equality. Then we've got the commutative property and the associative property. Commutative property is the one where I can say A times B is the same as B times A, or we can do that with addition, right? A plus B is equal to B plus A. I remember this one by thinking about the word commute, which is in the commutative property. So you can get to school in more than one way. Your commute to school could probably be different. One might take longer, and that's not really the point here, but I could go down 92nd Street or I could go down 76th Street to get to DSHA. The associative property is the one where you are grouping things. So A times B in parentheses times C is the same as A times B times C, right? We're grouping things differently, who you associate with, who your group is. And again, we can do this with addition too. So A plus B in parentheses plus C is going to be the same as A plus B plus C. These properties only work with addition and multiplication, so be sure you know that. And then last but not least, we got a couple additional properties. We've got the multiplication property of equality and the additive addition property of equality. So the multiplication one says if A is equal to B and X is equal to Y, then A times X is the same as B times Y. And actually, the addition property is the same start. So if A is equal to B and X is equal to Y, then we can do the same thing, but with addition. A plus X would be the same as B plus Y. Guess what? That was section P.3. So P.4, lines in the plane. Hopefully this is another super easy section for us, but we're going to brush up on it anyway. So let's remind ourselves, what is slope of a line? Often we use m, and it's known as rise over run, or change in y over change in x, or y2 minus y1 all over x2 minus x1. All right, point slope form of a line, we need a point and a slope. So that's the y minus y1 is equal to the slope times x minus x1. We also want to look at slope-intercept form. So when we have a slope and an intercept, that is our y equals mx plus b. Of course here, b is our y-intercept. And last but not least, the form that we don't often use, but still good to remind ourselves of, is the general form. In the general form, we basically rearrange the slope-intercept form to look like a times x plus b times y is equal to c, and a, b, and c are all integers, meaning they're not fractions, And specifically, A and B are positive. So it's really all about rearranging slope-intercept form or point-slope form into this ax plus by is equal to c. The other thing this section talks about is what it means to be parallel, what it means to be perpendicular. Parallel lines, we know, look something like this. That was not perfect. That's okay. Remember, the symbol for parallel is two little carrots like that. And what do we know about these lines? They have the same slope. Perpendicular lines, we know, meet at a 90-degree angle. So that was, oops, that was not a very good 90-degree, but you get it. And perpendicular lines have opposite reciprocal slopes. Opposite meaning negative, and reciprocal meaning you flip the fraction. All right, let's do section P.5 too. So P.5 is about solving equations graphically, numerically, and algebraically, which seems like a lot. And we'll go over this again with some examples in class. But the first question is, what does it mean to actually solve an equation? And to solve an equation means to find a solution or find the value that makes the equation true. So a really simple example, I'll just do this. If I have x plus 1 equals 4, the solution to solve this would be x is equal to 3. If I plug in 3 here, I make that equation true. A quadratic equation is a very specific type of equation in a quadratic form. The general is a x squared plus bx plus c is equal to 0. And specifically here, a, b, and c are all real numbers. And a is not equal to 0. If a was equal to 0, then you wouldn't have that x squared term, and you would not have a quadratic. All right, here's an example of a quadratic, and I'm asking, how do we solve this? I'm not asking you to solve it, so don't start doing that quite yet. But brainstorm in your head, what are ways that we can solve this? One way is to factor. Right? Set it so that it's x plus something times x plus something else equals 0. And then you would set each binomial, equal to 0 and solve. Another thing we could do here is we could use the quadratic formula. Which we will actually talk about on a later slide, so I'm not going to write down the quadratic formula. We could use our calculators to graph this function, and what we would see is a parabola, right? A shape that looks something like this. And if we are looking for the zeros, we'd be looking for these places where it hits the x-axis, otherwise known as our x-intercepts. And last but not least, we could use a method called completing the square. So we could complete the square. Again, I'll show you that in a little bit. I mentioned that I would have the quadratic formula up, so here's what we got. Maybe you were like me in grade school and had to learn this to the tune of, I don't know what song it was. X equals negative b plus or minus the square root. What is that? Pop goes the weasel. All right, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's our quadratic formula. Definitely need to know that. I'm going to give you the steps to completing the square, You may or may not remember this, and so we will definitely be going through an example in class. But remember, this is when we have a quadratic that looks like this, ax squared plus bx plus c. So the first step is to make sure that a is equal to 1. If it is not, you want to divide everything by a. Step 2 is to move c to the right side. So it would look like this. It would be x squared plus bx is equal to c. I didn't make it negative because technically c is just a constant and it can be either positive or negative. Step 3 then is to add the quantity b divided by 2 squared to both sides. So it's going to look something like this. X squared plus bx plus b over 2 squared is equal to, here, let me move this over, is equal to c plus b over 2 quantity squared. Step 4 is to factor the left side. And step 5 then is to solve. We are going to do an example and I will show you a really fun tip for this step 4 when we are in class. But I only have one other thing to show you, and it's solving equations that have absolute value. So, sorry, I wanted to pause and hide that problem because you don't need it yet. So solving equations with absolute values, you're going to do two things. You're going to first isolate the absolute value. And then you are going to set up two equations. I'm going to just say equations and solve. We will go into more detail in class. Have a great day.